Okay, now welcome to Mill Lab number 10. We're going to talk about the wonderful world of subprograms. Now, this is the first video in a two-part series, and what we're going to do is we're going to convert these hole patterns right here into from polar, which they're given to us in polar right here, polar coordinates, to rectangular coordinates. We've already done that in another video, but it doesn't hurt to revisit this because this is a little complicated. We're going to have to use some trig to do this one, and it's a little bit different. Here's the part we're going to do. I'll tell you a little bit about subprograms right now. Why are we going to use a subprogram to do this part? Uh, a subprogram, first off, is a program within a program. And whenever we've got repetitive part features, and in the example I've got one bolt pattern, bolt pattern A, bolt pattern B, C, and D, okay? And they're all the same. They're just in different locations. So whenever you look at something that has the exact same identical part features and they're reproduced or repeated on the part, that's a good application for a subprogram. Now, like I said, I'm going to tell you more about subprograms in the next video and how to structure them and things like that, and how to put them into the main program. So, excuse me. One of the things I want to point out, of course, is X0, Y0 is at the lower left-hand corner of the part. Z0 is going to be on the top of the part, which in this case is this right here. Notice that they do dimension the holes to full diameter, so we're going to talk about that. That's being different. So we're going to use some different stuff here. So the first thing we're going to do is we're going to go ahead and like I said, convert the polar coordinates. So let's see what we got here. It says we've got 125 thousandths diameter holes. That's an eighth of an inch, and there's 6 of them, and they're equally spaced on a 1-inch diameter bolt hole circle. Now they're calling the holes H1, H2, H3, H4, H5, and H6. All right, I just got 1, 2, 3, 4, 5, 6 over here. I'm not going to put the H numbers up there. I think you'll do fine without it. So notice that the bolt holes do only 2 of the bolt holes in this bolt hole pattern, okay, and these repeating bolt hole patterns land on the x-axis. The other 2 do not land on the y-axis, so we've got to do a little bit of different work here. All right, so let's get the calculator up here, and let's bring it up here and go ahead and turn it into scientific because we're going to need the scientific view. So bring that over here, bring it right here. There we go. Uh, As we recall last time, let's make sure this particular calculator works a little bit different than the others. I believe I put in 30 degrees and then hit the sign button, which should be 0.5. Yeah, that's how that one works. Others you put in, you hit sign and then 30 degrees and then hit enter. So that's why I always have to check that. This is the TI's 80s, and all the TIs do it like that. So that's why I was double checking. So let's clear that out of there. Now, as you remember, you may remember the last time we did bolt hole circles, we went ahead and said, guess what? We're going to go ahead and use the sine of an angle and the cosine of the angle to come up with both the x and the y coordinates. Now, okay, so let's do our givens first. We'll just use this one here. This is the one dimensioned. Again, these are all 4 identical, A, B, C, and D. They're just in different locations, which again shows me that I can use a subprogram. And this subprogram, the advantages of subprograms, there's just a whole lot. One of the big things is that it will make the length of our program much shorter. Okay, it'll also, you know, make it so that I don't have to type as much. Now, with copy and paste, a lot of you are going, well, we could have done that just with copy and paste. Yeah, we can do what we're going to do with copy and paste just fine, but your program will be much longer. Now, so let's just get these out of the way here. Okay, so we'll start with hole number 1, so which is H number 1. So if we look at this, I got a 1-inch diameter bolt hole circle. Now it's meant 1 inch from there to there. So from the center of the bolt hole circle, which is where we're going to start, we're going to move, we're going to do a datum shift. Now we're not going to use a G55 or a G56 or G57 or G58, or we will use G54 to establish this X0, Y0 on the part, but we're going to use a G52, and we're going to show you how that works. And that's called a datum shift, and it's a pretty cool little function. Unfortunately, some of your less sophisticated controls and your older controls, anything that's 2000 and older, like the year 2000 probably may not support a G52. So anyway, we'll talk more about the G52 later on. So let's look at that. So H1 is given to us. So H1, so that's hole number 1. So let's get this and tab over here. Bring that back up here. That one is, looks like it's going to be, well, X is going to be 0.5. And I'm going to bring that back a little bit here so I can, yeah, there's X is going to be 0.5 and Y is going to be 0. All right. There. I'm going to have to do that way. Okay, so hole number 4, H4, is also given to us. It's just the inverse, if you will, of H4. So I go here, and I'm going to go 0.500, and I'm just going to space that out there real quick so it lines up. There we go. Okay, but that's not, it's not going to be, it's going to be a minus, because remember, anything on this side. Now what we're going to do is we're going to shift our datum to the center of these bolt hole patterns. Again, it makes the math a whole lot easier. I don't have to add these distances to everything. So yeah, minus 0.5 looks just great. I'll take one space out of that. Delete. Yeah, that looks great. Minus 0.5. And Y, of course, is still going to be 0. So I'll put a 0.0 there. This time we won't get crazy with it. Okay, put one more back one more, delete. What happened there? Enter. Okay, here we go, delete. There we go, Control S. Okay, so those are our givens. Hole 1 and hole 4, they're given to us. Remember, we're coming from the center of the bolt hole circle. It's a ½ inch diameter bolt hole circle, or it's an inch diameter bolt hole circle from there to there, so it's a ½ inch from there and a ½ inch from there. So there's the coordinates of those two holes. What we need to do is come up with H2, H6, H5, and H3. Okay, so let's just go to H2 first. All right, now the angle, remember I said what you want to do is you're going to take the angle, so we want to know the angle. Let's zoom into that a little better here. Let's do some more marquee zoom here. I'll zoom into this a little bit better here. There. And I can scroll up and scroll over here. So what we want to do is this angle from there to there is the first thing we got to come up with. Now, we know these are equally spaced. So I got 6 holes. Let's bring up the calculator again. So I got 6 holes equally spaced on a 360-degree circle. So if I take 360 degrees and divide it by 6, I should equal up with 60 degrees. So that means it's 60 degrees from that hole to that hole, from that hole to that hole, from that hole. You get it, right? But we need to know how far it is from here to there to do this first for H2. And that's not given to us. Okay? Now, we don't know what that angle is. Well, we do know this. We know it's 90 from there to there. We know it's 60 from there to there. Well, if it's 60 from there to there, and it's 90 from there to there, it has to be 30 from there to there. So yes, this angle is going to be 30 degrees. So let's just go ahead and do again. Let's clear this out over here. Clear. And I'm going to put in 30 and hit sign, which we know is 0.5 there. Now I'm going to take it times the radius. Well, the radius of the bolt hole circle is 500 thousandths. All right. So that's times. So we're going to multiply it. Multiply 0.5, that's all you have to put in there, 250 thousandths. Now, it's obviously not 250 thousandths from there to there, so it's 250 thousandths. So I can go up here and say, I put in 0.250, we'll space it over there, okay, hit Control S if you haven't done that. You need to do one of these charts, just to keep track of all your holes. All right, so I got 250 thousandths there. So now I'm bringing up my calculator again. Let's clear that sucker back out. Again, we're going to put 30 degrees. We're going to use the cosine of 30 degrees, which is that right there, drawn out to incredible amounts, and multiply it again, multiply it by the radius, all right, which the radius again is 0.5. So times 0.5 equals. So that's how far I got to go up. So that's my Y value, 0.433. So I'm going to put 0.433 here, put my insertion point here, and just tab this over there to make it look good. Hit Control S. Now at this point, really, excuse me, I did not hit Control S there. I hit just S. Control S is come save, and it's got hole coordinates, MILLAB number 10. So that's for hole number H2. Now let's go to H3. That is all we have to do, but I'm going to do this another time. It's still 30 degrees from there to there, 60 degrees from there to there, 90 degrees from there to there. So as long as you know it's 60 from here to there and 90 from there to there, you take 60, subtract it from 90, you get 30 between there. So we'll do that whole thing again just so that you can see it. Whole thing, haha. Okay, so we're going to put in 30, hit the sign button, we know it's 0.5, and multiply that by the radius, which is multiply there, 0.25. So we know right here that this is again our x-axis, and that's h3. So now that's a minus value, so I need to put that in there, minus 0.250, and we'll tab it on over there, space it on over there in this case. And one more, make it look nice. Okay, Control S, there we go. Now, how far up? Again, it's going to be the same as the y was before. I'll show you. We'll do that same calculation again. I'm going to put in 30 degrees and hit the cosine, and then multiplied by 0.5, which is the radius of the bullet hole circle, equals 0.433. So there we go. And all I'm going to do this time is I'm going to copy, because no reason to type it, copy, and put my insertion point right there and paste. Boom. And hit Control S there to save that. All right, let's look at H5. H5 again is the same, okay? Now you could use 60 degrees here to come up with that, but it's really best to use this one right here. You'll have to use something different than the sine and the cosine, okay? Oh, let's go back up here, clear that out. For H5, again, I've got 30. Really, do I need to do it? I'll do it just one more time. That's the last time. I'm not going to do it for H6. You see, we really only had to do one trig problem for this one. Now, so 830, and I'm again multiplied by the radius. Oops, that did not work out right. I didn't hit sine. There. Multiplied by the radius. Anytime you multiply something by 0.5, it's the same as dividing it by 2 if you didn't know that. So, yeah, there we go. So whole 5, let's take a look at that. That's going to be x, and it's because it's obviously 200. It's a lot shorter from there to there. So I'm going to put in, I'll just put in minus 0.25 here, minus 0.25, and we'll tab it over and Control S. Now let's go back and clear that back out. 30 degrees again, hit the cosine, and then I'm going to multiply that by the radius. There it is, 0.433. So you can pretty much trust me now. Now, is that a minus? It is a minus. So don't mess your signs up, because otherwise you'd be drilling the wrong holes. All right, Control S. Now I'm going to look at hole number 6 and know that x is going to be minus 0.25. I'm just going to go ahead and copy that, tab it over to right there and paste it. Okay, and then I also know that this is going to be a minus in y, because remember x0 and y0 is going to be, we're always calculate from the center of the bullet hole circle. So bring that over here, copy, paste, Control S. There, I have done the coordinates all on my bullet hole circle. Now let's take a look here. I want to go back to like 75%. I think that's where I was. Now it looks like I might have been at 70. It's easy to go in. It's not so easy to come back out. Yeah. Okay, so 6 equally spaced holes in a 1-inch diameter bullet hole circle. I want to make sure that my minus signs are right. So hole 3, x is going to be a minus, y is going to be a positive. Hole 4, x is going to be a negative, y is just going to be 0. Hole 5, x is 0, x is negative, and y is negative. So I'm looking, yeah, making sure I got my symbols right. I know my numbers are right. And hole 6, of course, hole 6 is wrong. See, that's why I double checked that, because I put down a minus 250. I would have drilled this hole right here, H5, twice. I don't want that minus symbol there. Delete it. space that over, hit Control S. See, that is a good reason to do that, because especially when you copy and paste, you can get a little overconfident. Remember, while copy and pasting can save you errors, if you have errors in what you're copying, you're going to end up with errors in your final data. And this is a terrible place to start making errors right here. Now, I've got that up there, okay? So, like I said, I'm going to hit Control S again to make sure I got that saved. All right. So having done all that, this is just a simple little quick down and dirty how to calculate those hole patterns. Now a lot of people are going, well, this one's 1 inch up and 750 over, or all this. Like I said, we're going to do a datum shift. So I'm going to show you that in the next video, okay? So this is the first one you want to watch. I'll make sure that you understand that. So see you in the next video.